Hello friends, today we will learn about sterilization. What do you mean by sterilization? Methods of sterilization, physical methods, chemical methods, and testing of disinfectants. All we'll discuss in this video. So let's begin. First of all, introduction. Microorganisms are responsible for contamination and infection. They are present all around. The aim of sterilization is to remove or destroy them from the materials or from surfaces. Now, sterilization. It is a process by which an article, surface, or medium is made free of all microorganisms either in the vegetative or spore form. Now let's know about disinfection. It means the destruction of all pathogens or organisms capable of producing infections but not necessarily spores. All organisms may not be killed but the number is reduced to a level that is no longer harmful to health. Now let's know about antiseptics. These are chemical disinfectants which can safely be applied to living tissues or are used to prevent infection by inhibiting the growth of microorganisms. Now let's know about asepsis, the technique by which the occurrence of infection into an uninfected tissues is prevented. Now let's know about uses of sterilization or disinfection. Sterilization of materials instruments used in surgical and diagnostic procedures. For media and reagents used in the microbiology laboratory. In food and drug manufacturing to ensure safety from the contaminating organisms. Now let's know about the methods of sterilization. There is two methods. First is physical method and another is chemical method. In physical method, sunlight, heat, filtration, radiation are used. And heat in heat method, that is two types of heat, dry heat and moist heat. Now second method is chemical methods. In chemical methods, alcohols, aldehydes, phenols, halogens, oxidizing agents, salts, surface active agents, dyes, vapor phase disinfectants are used. Now let's start with in brief. Let's start briefly with physical method, that is sunlight. Let's know about sunlight, how it sterilizes. Sunlight has an active germicidal effect due to its content of ultraviolet rays. It is natural method of sterilization in cases of water in tanks and rivers and lakes. Now let's know about second method is heat. Heat is the most reliable and commonly used method of sterilization. It should be the method of choice unless contraindicated. Two types of heats are used, that is dry heat and moist heat. Principle: dry heat kills the organisms by denaturation of bacterial protein, oxidative damage, and by the toxic effect of elevated levels of electrolytes. However, the possibility of DNA damage is also incriminated as one of the mechanisms of inactivations of microorganisms. Second is moist heat kills the microorganisms by denaturation and coagulation of proteins. Now let's know about factors influencing nature of heat, dry heat or moist heat. Temperature and duration. Second point is temperature and duration. The time required for sterilization is inversely proportional to temperature to which organisms are exposed. Third is characteristic of microorganisms and spore present. Bacterial spores are minute. Most vegetative bacteria, fungi and viruses are killed in 30 minutes at 65 degrees centigrade by moist heat. Now let's know about type of material. A high content of organic substances tend to protect the vegetative form and spores against the lethal action of heat. Materials containing organic substances require more time for sterilization. Proteins, sugars, fats, and starch are some of the organic substances. Now let's know about dry heat sterilization. In dry heat sterilization, there are some procedures. First is red heat, flaming, incineration, hot air oven. First is red heat. First point is red heat. Let's know about the red heat. Inoculating wires or loops, tips of forceps and needles are held in the flame of a red heat of a Bunsen burner till they become red hot. Now let's know about flaming. Glass slides, scalpels and mouths of cultural tubes are passed through Bunsen flame without allowing them to become red hot. Now let's know about incineration. By this method, infective material is reduced to ashes by burning. Instrument named incinerator may be used for this purpose. Soiled dressings, animal carcasses, bedding and pathological materials are dealt with this method. Now, fourth method is hot air oven. It is the most widely used method of sterilization by dry heat. The oven is electrically heated and is fitted with a fan to ensure adequate and even distribution of hot air in the chamber. It is also fitted with a thermostat that maintains the chamber air at a chosen temperature. Now let's know about temperature and time. 160 degrees centigrade for 2 hours. Holding time is 2 hours is required for sterilization. However, alternative temperatures holding time includes 170 degree for 1 hour and 180 degree centigrade for 30 minutes. Now let's know about the use. It is used for sterilization of glasswares like glass syringes, petri dishes, flasks, pipettes and test tubes. Second point is surgical instruments like scalpels, scissors, forceps, etc. can be sterilized in this method. Temperature high by giving high temperature. Third point is chemicals used as liquid paraffin, fats, sulfonamides and sulfonamide powders, etc. Now let's know about the precautions. It should be it should not be overloaded. Second point, the material should be arranged in a manner which allows free circulation of air. Third point, material to be sterilized should be perfectly dry. Test tubes, flasks, etc. should be fitted with cotton plugs. Fifth point, petri dishes and pipettes should be wrapped in paper. Sixth point, rubber materials except silicone rubber or any inflammable material should not be kept inside the oven. The oven, next point, seventh point, the oven must be allowed to cool for 2 hours before opening the doors since the glasswares may crack by sudden cooling. Now let's know about sterilization control. The spores of Bacillus subspecies Niger NCTC 10075 or ATCC 9372 are kept inside the oven. These spores should be destroyed if the sterilization is proper. Thermocouple may also be used. Brown's tube with green spot is available. After proper sterilization, a green color is produced after 2 hours at 160 degrees centigrade. Now let's know about moist heat sterilization. This method of sterilization may be used at different temperature, like at temperature below 100 degrees centigrade. Second is at temperature of 100 degrees centigrade and at a temperature above 100 degrees centigrade. Now let's know about first point at a temperature below 100 degrees centigrade. Pasteurization of milk. Here pasteurization of milk occurs. Here two types of methods, that is Holder method 63 degree for 30 minutes and flask method, that is 72 degree centigrade for 20 seconds, followed by cooling quickly to 13 degree centigrade or lower are used. All non-sporing pathogens such as Mycobacteria, Brucellosis and Salmonella are killed except Coxiella Borneti, which being relatively heat resistant may survive in Holder method. Second point is inspissation. Some serum or egg media such as Lowenstein, Jensen's and Loffer's serum are rendered sterile by heating at 80 to 85 degrees centigrade temperature for half an hour daily on 3 consecutive days. This process of sterilization is called inspissation. The instrument used is called inspissation. Now, let's know about third point, that is vaccine bath. Bacterial vaccines are sterilized in special vaccine baths at 60 degrees centigrade for 1 hour. Serum or body fluids can be sterilized by heating for 1 hour at 56 degrees centigrade in a water bath on several successive days. Now let's know about the fourth point, that is low temperature steam formaldehyde sterilization. In short, LTSF. Items which cannot withstand the temperature of 100 degrees centigrade may be sterilized by a method known as low temperature steam formaldehyde sterilization. In this method, steam at subatmospheric temperature at the temperature of 70 degrees centigrade with formaldehyde vapor is used. Bacillus stereothermophilus has been used as biological control to test the efficacy of LTSF sterilizers. Now let's know about the second point, at the temperature of 100 degrees centigrade. At temperature of 100 degrees centigrade, moist heat sterilization how occurs. Let's know. First is boiling. Here first point is boiling. Boiling for 10 to 30 minutes may kill most of the vegetative forms by many spores withstand boiling for a considerable time. When better methods are not available, boiling may be used for glass syringes and rubber stoppers. It is not recommended for the sterilization of instruments used for surgical procedures. Now, let's know about tyndallization. Steam at 100 degrees centigrade for 20 minutes on 3 successive days is used. This is known as tyndallization or intermittent sterilization. The principle is that the first exposure kills all the vegetative forms, and in the interval between the heating, the remaining spores germination into vegetative forms which are killed on subsequent heating. It is used for sterilization of egg, serum or sugar containing media which are damaged at higher temperature of autoclave. The instrument commonly used is Koch's or Arnold's steam sterilizer. Steam sterilizer at 100 degrees centigrade. For steam sterilizer at 100 degrees centigrade for 90 minutes. Koch or Arnold steam sterilization is usually used for this purpose. For this media which are decomposed at high temperature of autoclave, the articles are kept on the perforated tray through which steam can pass. They are exposed to steam at atmospheric pressure for 90 minutes. Most of the vegetative forms are killed by this method except the thermophils. Now let's know about the third point, that is at a temperature above 100 degrees centigrade how how steam sterilization occurs. Water boils when its vapor pressure equals boils when its vapor pressure equals that of the surrounding atmosphere. When the atmospheric pressure is raised, then the boiling temperature is also raised. At normal pressure, water boils at 100 degrees centigrade, but when pressure inside a closed vessel increases, the temperature at which water boils also increases. This principle has been applied in autoclave and pressure cooker. Now let's know about autoclave. First principle of autoclave. Steam above 100 degrees centigrade or saturated steam has a better killing power than dry heat. Bacteria are more susceptible to moist heat as bacterial protein coagulates rapidly. Saturated steam can penetrate porous material easily. When steam comes into contact with a cooler surface, it condenses to water and liberates its latent heat to that surface. For example, 1600 ml of steam at 100 degrees centigrade and at atmospheric pressure of condenses into 1 ml of water at 100 degrees centigrade and releases 518 calories of heat. This the large reduction in volume shocks in more steam the same site, and the process continues. The temperature of the article is raised that of steam. The condensed water produces moist conditions for killing of microbes present. Now let's know about the components of autoclave. Autoclave is a modified pressure cooker boiler. It consists of a vertical or horizontal cylinder of gunmetal or stainless steel in supporting iron case. The lid is fastened screw clamps and rendered airtight by a asbestos washers. The lid bears a discharge tap for air and steam, a pressure gauge, and a safety valve. Heating is generally done by electricity. The steam circulates within the jacket and is supplied under high pressure to inner chamber where materials are kept for sterilization. Now let's know about the procedure. The cylinder is filled with sufficient water and the material to be sterilized is placed on the tray. The lid is closed with the discharge tap open. The heater is put on. Safety valve is adjusted to the required pressure. After boiling of water, the steam and the air mixture is allowed to escape till the air has been displaced. This can be tested by leading the escaping steam air mixture into a pail of water through rubber tubing. When the air bubbles stop coming in the pail, it indicates that all the air has been displaced. The discharge tap is now closed. The steam pressure rises inside and when it reaches the desired set level, the safety valve opens and the excess steam escapes. From this point, the holding period is counted. After the holding period, the heating is stopped and autoclave allowed to cool till the pressure gauge indicates that the pressure inside is equal to the atmospheric pressure. The discharge tap is opened slowly and air is allowed to enter the autoclave. The lid is now opened and then sterilized materials removed. Now let's know about the sterilization condition. Temperature should be 121 degrees centigrade. Chamber pressure is 15 lb per square inch. Holding time is 15 minutes. This condition is generally used. However, sterilization can also be done at higher temperature at 126 degrees centigrade. That is 20 lbs per per square inch for 10 minutes at 133 degrees centigrade for 3 minutes. Now let's know about the uses. To sterilize culture media, rubber material gowns, dressing, gloves, etc. It is particularly useful for materials which cannot withstand the higher temperature of hot air oven. For all glass syringes, hot air oven is a better sterilizing method. Now let's know about the precautions. The air must be allowed to escape from the chamber as temperature of air steam mixture is lower than that of pure steam. Materials should be arranged in such a manner as to ensure free circulation of steam inside the chamber. Now let's know about the sterilization control. Thermocouple. It is record the temperature directly by a potentiometer. Second point, bacterial spores. Spores are Bacillus stereothermophilus are used as the test organism. This organism has an optimum growth temperature of 55 to 60 degrees centigrade and its spores are killed in 12 minutes at 121 degrees centigrade. An envelope containing a filter paper strip impregnated with 10 to the power 6 spores are placed inside the autoclave during sterilization. After sterilization is over, the strip is inoculated into the suitable recovery medium and incubated at 55 degrees centigrade for 5 days. Spores are destroyed if sterilizing conditions is of autoclave are proper. Now let's know about chemical indicators. Brown's tube contains red solution which turns green when exposed to temperature of 121 degrees centigrade for 15 minutes in autoclave. Now autoclave tapes. Fourth point is autoclave tapes. Now let's know about the filtration. This method of sterilization is useful for substances which get damaged by heat process. Example, sera, sugars, antibiotic solutions, etc. Uses of filtration. Let's know about the uses of filtration. The use to sterilize sera, sugars and antibiotic solutions. Second is separation of toxins and bacteriophages from bacteria. Third point, to obtain bacteria free filtrates of clinical samples for virus isolation. Fourth point is sterilization of hydrated fluid. Fifth point, filter disc retain the organism which can then be cultured. Example, testing of water samples for cholera vibrios or typhoid bacilli. Sixth point is purification of water. Now let's know about limitation. The pore size of filter is around 0.75 micrometer in diameter, which retains bacteria but allows viruses and mycoplasma to pass through filter. Therefore, filtered preparations are not safe for clinical use. Now let's know about types of filters. Candle filter. Example, Burkefield Chamberlain filter. Second is asbestos disc filters. Example, that is sage filter. Third point, sintered glass filters, membrane filters, air filters, syringe filters. It is normal practice to use positive or more usually negative pressure by suction pump to enhance filtration. First is candle filters. These have been used widely for purification of water for industrial and drinking purposes. These filters are usually made in the form of hollow candles. The liquid to be filtered is passed through the candle. They are available in different grades of porosity. Candle filters are of two types. Diamoseous earth filters, that is example Burkefield, and second is unglazed porcelain filters, example Chamberlain. Now let's know about second point, that is asbestos disc filters or in short Say's filter also we can say. These are made of asbestos, that is magnesium silicate. The filtered disc is supported on a metal mount. The filter is attached to a vacuum flask through a silicon rubber bung. After use, the filter disc is discarded. Each time a fresh disc is used and the outfit is sterilized by autoclaving. These filter discs are available in different grades. Third point is sintered glass filters. These are prepared by fusing finely powdered glass particles. These are available in different pore sizes. Fourth point is membrane filters. Membrane filters are made up of cellulose esters. These are routinely used in water analysis, sterility testing, and for the preparation of solutions for parental use. Nitrocellulose millipore membrane filters are widely used. Membrane filters are available in pore sizes of 0.015 to 12 micrometer. The 0.22 micrometer filter is the most commonly used because the pore size is smaller than the bacteria. For bacterial count of water, known amount is water is filtered them the filter through the membrane filter disc. The upper side filter disc is placed on a culture medium and incubated. The colonies developed on medium and viable counts can be calculated counting the colonies. Now let's know about air filters. These filters are used deliver clean bacteria free air to a cubicle of a room. High efficiency particular air. High efficiency particular air, in short HEPA filters are used in air filtration laminar airflow system in microbiological laboratories. HEPA filters are remain used in the particles of 0.3 micrometer or larger. Now next type is syringe filters. Syringes fitted with membrane of different diameters available. For sterilization, the fluid forces through the disc, pressing the piston of the syringe. Now let's know about radiations. Two types of radiations are used: sterilization, that is ionizing, and non-ionizing. First is ionizing radiation. Ionizing radiations include gamma rays, X-rays, and cosmic rays. They are very high penetrating power. They are highly lethal to all cells, including bacteria. They damage DNA by various mechanisms. Gamma radiations are commercially used for the sterilization of disposable items such as plastic syringes, swabs, culture plates, cannulas, catheters, etc. This method is also known as cold sterilization because there is no appreciable increase in temperature. Bacillus pumila has been used for testing the efficacy of ionizing radiations. High energy electron radiation is not used widely in medicine. Now let's know about non-ionizing radiations. These include infrared and ultraviolet radiations. Infrared is used for rapid mass sterilization of syringes and catheters. Ultraviolet radiation with wavelength of 240 to 280 nanometer has marked bactericidal activity. It acts by denaturation of bacterial protein and interference with DNA replication. UV radiation is used for disinfecting enclosed areas such as bacteriological and laboratory and inoculation hoods, laminar flow, and operation theaters. Most vegetative bacteria acceptable are susceptible to UV radiation by spores are highly resistant. Susceptible viruses is variable. Now let's know about the chemical method. A variety of chemical agents are used as antiseptics and disinfectants. An ideal antiseptic or disinfectant should have some criteria. First point, have wide spectrum of activity and be effective against all microorganisms including bacteria, in bacteria means both vegetative and spore forms, viruses and protozoa and fungi. Second point, it should act in the presence of organic matters. Third point, should have high penetration power and quick action. Fourth point, be stable and effective in acidic as well as in alkaline conditions. Next point, it should not corrode metals. Sixth point, be compatible with other disinfectants. Seventh point, not cause local irritation. Eighth point, should not be toxic if absorbed into circulation. Be safe. Next point is ninth point, be safe and easy to use. 10th point, be easy, available and cheap. The disinfectant which possess all these criteria is yet to be found. There are some factors influence the potency of a disinfectant. Let's know about the factor. First is concentration, second is time of action, third is pH, fourth is temperature, fifth is presence of organic matter. Disinfectants can be divided into three groups: high level disinfectants, intermediate level disinfectants and low level disinfectants. Let's know about the high level disinfectants. The effectiveness of high level disinfectants may be equivalent to that of sterilization. These disinfectants are used for certain types of endoscopes, cytoscopes, and surgical instruments with plastic components which cannot withstand the sterilization procedure, such as autoclaving. The high level disinfectants include glutaraldehyde, hydrogen peroxide, para-acetic acid, and chlorine compounds. Next point is intermediate level disinfectants. Intermediate level disinfectants may not be effective against bacterial spores. Hence, these disinfectants are used for instruments. Example, laryngoscopes, fibroscopic endoscopes, where contamination with spores and other highly resistant organisms is unlikely. The intermediate level disinfectants include alcohols, iodophores, and phenolic compounds. Now let's know about low level disinfectants. Many organisms can survive on exposure to low level disinfectants. These disinfectants are used for items which come in contact with patients but they do not penetrate into tissue. Stethoscopes, electrocardiogram, electrodes, etc. are examples of such items. Now let's know about the alcohols. Ethyl alcohol and isopropyl alcohol are the most frequently used. They act by denaturing bacterial proteins. They rapidly kill bacteria, including tubercle bacilli, but they have no sporicidal or virucidal activity. However, human immunodeficiency virus (HIV), in short, HIV is susceptible to 70% ethyl alcohol and 35% isopropyl alcohol in the absence of organic matter. They are used mainly as skin antiseptics. To be effective, they should be used at a concentration of 60 to 70% in water. Isopropyl alcohol is preferred to ethyl alcohol as it is a better fat solvent, more bactericidal and less volatile. Methyl alcohol is effective against fungal spores and is used for treating cabinets affected by them. Methyl alcohol vapor is toxic and inflammable. Now let's know about aldehydes. First is formaldehyde. It is marked bactericidal, sporicidal and virucidal. It is used both as aqueous solution and in gaseous form. In 10% aqueous solution of formalin is routinely used. It is active against amino group in the protein molecule. Now let's know about the use. Preservation of tissues for histological examination. Second is to sterilize bacterial vaccines. Third is to prepare toxoid from toxin. Fourth point is for killing of bacterial cultures and suspensions. Fifth point for destroying anthrax spores in hair and wool. Formalin gas has been known as vapor phase disinfectants. Now let's know about glutaraldehyde. It is effective against bacteria including M. tuberculosis, fungi and viruses including human immunodeficiency viruses and enteroviruses. It is less toxic and irritant to the eyes and skin than formaldehyde. It is used as 2% buffer solution. It is available commercially as Sidex. It can be used for delicate instruments having lenses. Now let's know about the uses. For sterilization of cytoscopes, endoscopes and bronchoscopes. Second point, the sterilization to sterilize plastic endotracheal tubes, face mask, corrugated rubber and aesthetic tubes and metal instruments. Now let's know about phenols. Lister, the father of antiseptic surgery, first introduced use of phenol in surgery in 1867. Phenols are produced by distillation of coal tar between temperatures of 170 degrees centigrade and 270 degrees centigrade. The lethal effect of phenols is due to cell membrane damage, thus releasing cell contents and causing lysis. Phenol 1% has bactericidal action. It is readily absorbed by skin and causes toxicity. Certain phenol derivatives like cresol, chlorhexidine, chloroxylenol, and hexachlorophene are commonly used as antiseptics. Now let's know about cresols. Lysol is a solution of cresols in soap. It is most commonly used for sterilization of infected glass was whereas glasswares, cleaning floors, disinfection of excreta. They are not readily inactivated by the presence of organic matter. They are active against a wide range of organisms. Now let's know about chlorhexidine. Salvon is widely used wounds pre-operative disinfection of skin as bladder irrigant etc. It is bactericidal at high high dilution. They are more active against gram positive than gram negative bacteria with no action against tubercle bacteria. Bacteria with no action against tuberculosis bacilli or spores and have very little activity against viruses. They have a good fungicidal activity. Chloroxylenol. It is an active ingredient of Dettol. Chloroxylenol. It is less toxic and less irritant. It is readily inactivated presence of organic matter. It is inactive by Pseudomonas. Now let's know about hexachlorophene. It is more active against gram-positive than gram-negative bacteria. It is applied on skin as prophylaxis against Staphylococcus infection. It is bacteriostatic at very high dilutions. It is potentially toxic and should be used with care. Now let's know about halogens. Chlorine and iodine are two commonly used disinfectants. These are bactericidal and are effective against sporing bacteria and viruses. Chlorine is used in water supplies, swimming pools, food and dairy industries. Chlorine compound in the form of bleaching powder, sodium hypochlorite and chloramine are also used. The disinfection action of all the chlorine compounds is due to release of free chlorine. When hypochlorite are added to water, the chlorine reacts with water to form hypochlorous acid, which is a strong oxidizing agent and effective disinfectant. The activity of chlorine is markedly influenced by the presence of organic matter. Bleaching powder or hypochlorite solution are the most widely form of used for human immunodeficiency virus infected materials. The hypochlorite have a bactericidal, fungicidal, virucidal and rapidly sporicidal action. Hypochlorite solution decays rapidly and should be prepared daily. It should not be used in the presence of formaldehyde as one of the reaction products is found to be carcinogenic. Chloramines are used as antiseptics for dressing wounds. Iodine in alcoholic and aqueous solutions is used as a skin disinfectant. It is actively bactericidal with moderate action against spores. It is active against M. tuberculosis and viruses. Like chlorine, it is also inactivated by organic matter. Compounds of iodine with surface active agents known as iodophores are claimed to be more active than the aqueous or alcoholic solution of iodine. Betadine is one example of commonly used iodophores. Now let's know about oxidizing agent. Hydrogen peroxide. Let's know about hydrogen peroxide. Hydrogen peroxide, in short H2O2, is effective against most organisms at concentration of 3 to 6%, while it kills all organisms including spores or at higher concentration. Mode of action is by liberating of free hydroxyl radical on decomposition of H2O2. These free radicals are the active ingredient in the disinfection process. H2O2 is used to disinfect contact lenses, surgical prostheses, and plastic implants. Now let's know about the peracetic acid. Peracetic acid is an oxidizing agent. It is one of the high-level disinfectant. The end of the end of the end one of the high level the end products, that is acetic acid and oxygen of this agent, are non-toxic. It is also used in plasma sterilization procedure. Now let's know about plasma sterilization. Plasma refers to any gas which consists of Electrons, ions are neutral particles. The formation of a low temperature plasma requires several devices. Chemical disinfectants such as H2O2 alone on a mixture of H2O2 and peracetic acid is used in this devices is introduced the plasma. The resulting UV radiations causes destruction of vegetative organisms and spores. Two commercial plasma sterilizers available are Sterile 100S sterilizer and Plaslight sterilizer. It is used for sterilization of surgical instruments. Now let's know about the salt. Salts of heavy metals have toxic effect on bacteria. The salts of copper, silver and mercury are used as disinfectant. They are protein coagulants and act by combining with sulfyl groups of bacterial proteins and other essential intracellular compounds. The merthiolate sodium ethyl mercurethiosalicylate is used in a dilution of 1 is to 10,000 for preservation of sera. Mercury chloride, once used as a disinfectant, is highly toxic. The thiomersal and mercurochrome are less toxic and are used as mild antiseptics. They have a marked bacteriostatic but limited fungicidal action. Copper salts are used as fungicides. Now let's know about surface active agents. Substances which alter energy relationship at interfaces, producing a reduction of surface tension, are known as surface active agents or surfactants. They are classified into anionic, cation, non-ionic, and amphoteric compound. Of these, the cationic surfactants have been the most important antibacterial agent. These act on the phosphate group of the cell membrane and also enter the cell. This results in loss of membrane semipermeability and the cell proteins are denatured. Quaternary ammonium compounds are the most important cationic surfactants. Although these compounds are bactericidal for a wide range of organisms, gram-positive species are more susceptible. They have no action on spores and tubercle bacilli. They are active agents against viruses with lipid envelopes and much less against non-enveloped viruses. The common cationic compounds are acetyl trimethyl ammonium bromide and benzyl alkonium chloride. The activity of these compounds is greatest at an alkaline pH. Acid inactivates them. Antibactericidal activity is reduced in the presence of organic matter. Anionic surface active agents like ordinary soaps render them inactive. The anionic compounds, example common soaps, have strong detergent but weak antimicrobial properties. These agents are most active at acidic pH. They are effective against gram-positive bacteria but are relatively ineffective against gram-negative species. The amphoteric compounds known as Tego compounds possess detergent properties of anionic and antimicrobial activity of cationic compounds. They are active against a wide range of gram-positive and gram-negative organisms and some viruses. They are active over a wide range of pH. The presence of organic matter reduces their activity. Now let's know about the dyes. Two groups of dyes, aniline dyes and acridine dyes have been used extensively as skin and wound antiseptics. Both are bacteriostatic in high dilution but have low bactericidal action. Aniline dyes include crystal violet, brilliant green, and malachite green. They are more active against gram-positive bacteria than gram-negative bacteria. They have no activity against M. tuberculosis, and hence the use of malachite green in the lowest Lowenstein Jensen medium makes it selective for isolation of tubercle bacilli. They are non-toxic and non-irritant to the tissues. Their activity is inhibited by organic materials such as pus. They interfere with the synthesis of peptidoglycan component of the cell wall. These dyes are used in the laboratory as selective agents in culture media. Now let's know about acridine dyes. Acridine dyes include acriflavine, euflavine, proflavine, and aminacrin. They are affected very little by the presence of organic material. They are also more active against gram-positive bacteria than gram-negative bacteria but are not as selective as the aniline dyes. These dyes are used in clinical medicine. They interfere with the synthesis of nucleic acids and proteins in bacterial cells. Gentian violet and acriflavine are two widely used dyes for skin disinfection, especially in gram-positive bacterial infections. Now, let's know about vapor phase disinfectants. Formaldehyde gas. This is employed for fumigation of operation theaters, wards, laboratories, etc. Formaldehyde gas is generated by adding 150 gram of KMNO4 to 280 ml formalin for 1000 cu feet of room volume. This reaction produces considerable heat and so heat resistant containers should be used. The doors should be sealed and left open for 48 hours. Sterilization is achieved in condensation of gas on exposed surfactants. The gas is irritant and toxic when inhaled. After completion of disinfection, the effect of or irritant vapor should be nullified and exposed to ammonia vapor. Now let's know about ethylene oxide. It is colorless liquid with a boiling point of 10.7 degrees centigrade. It is effective against all types of microorganisms including viruses and spores. It is a highly penetrating gas and readily penetrates some plastics. It acts alkylating the amino, carboxyl, hydroxyl and sulfhydryl groups in protein molecules. In addition, it reacts with DNA and RNA. It is a potential toxicity to human beings including mutagenicity and carcinogenicity. It is highly inflammable. It forms explosive mixture when concentration in air is greater than 3%. By mixing it with inert gases such as carbon dioxide, its explosive tendency can be eliminated. It is specially used for sterilizing plasma and rubber articles, respirators, heart lung machines, sutures, dental equipments and clothing. It is unstable for fumigation. Fumigation of rooms because of its explosive nature. It is irritant and personnel working with have to take precautions. Bacillus globigi, a red pigmented variant of Bacillus subtilis has been used for biological control for testing of ethylene oxide sterilizers. Now let's know about beta propiolactone, in short BPL. This is a condensation product of ketone and formaldehyde. It has a boiling point of 160 degree 63 degrees centigrade. Though it is a gas, it has a low penetrating power. It has a rapid action and is used in 0.2%. It is effective against all microorganisms including viruses. It is more effective for fumigation than formaldehyde. Unfortunately, it has some carcinogenic activity. BPL is used for inactivation of vaccines. Now, methods. Now let's know about testing of disinfectants. First is Rydell Walker test, Chick Martin test, Kelsey Sykes test, in use test. Now let's know about Rydell Walker test. In Rydell Walker test, suspensions containing similar quantities of organisms are submitted to the action of varying concentrations of phenol and of the disinfectant to be tested. The dilution of the test in infectant which sterilizes the suspension in a given time is divided by the corresponding dilution of phenol. This gives the phenol coefficient. The phenol coefficient does not, however, give any indication of how the test disinfectant will function practically in the presence of organic matter. Second is Chick-Martin test. Chick-Martin test is a modification of Rydell Walker test. In this test, disinfectant acts on the presence of organic matter to simulate natural conditions. Organic matter in the form of dried yeast or feces is included. Third point is Kelsey Sykes test. This test gives a measure of capacity of a disinfectant to retain its activity when repeatedly used microbiologically. It is also named as capacity test. The standard organism is added to the disinfectant in 3 successive lots of at 0 to 0, 10 and 20 minutes. These 3 lots are in contact with disinfectant for 8 minutes and samples are transferred at 8, 18 and 28 minutes respectively to a recovery medium. The disinfectant is judged by its ability to kill bacteria and not by comparison with phenol. The test is carried out under both clean and dirty conditions. Thus, it also measures the effectiveness of a disinfectant in the presence of an organic matter. Now, let's know about in-use test. The liquid phase of disinfectant solutions in actual use in hospital practice is examined quantitatively for variable organisms. A use dilution is then determined, which only very rarely yield a positive culture. The efficiency of a new disinfectant is determined by its ability to inactivate a known number of standard strain of a pathogenic staphylococcus on a given surface within a certain time. The results of such tests are generally more useful than those of phenol coefficient test and its modification. Finally finished. Any questions regarding this sterilization you can ask me in the comment box. To know more updates you can subscribe my channel. Thank you.